Hey guys, how's everything going? This is JSer. In this video, let's solve another problem from BFE.dev. It's 138, intersection of two sorted arrays. Given two sorted array of integers, find the elements that exist in both arrays. So this is two arrays. We have double 2, double 4, double 2, 1, 4, double 5. So the intersection should be 2, double 2, and 1, 4. All right. Okay, the arrays might have duplicate numbers like 2, 2, 4, the 2, 2 here. The order of the returning result doesn't matter. What is the time and space cost of approach? Well, the naive solution would be loop through the one shorter array, and then see if the other one has this element, right? So would be, suppose that n and m, we would say om. And for each number, we would search for the whole array to see if it has it. And because there's a duplicate, once we found one, we need to remove it from the array, right? So that costs us not extra time. Anyway, the OANM, big ONM, would be a nice estimation about the time and time complexity. So, but when we remove an element, we need to shift the index of the other elements, right? So that's not good. We may need to pre-process m AR2 and to count the element with a unique number, and then we could into a map, which is the number and count. So when we loop through the n again, we will just get the direct access, right? We get the direct access. So it's now become time would be O big O M, and update the number would be something like direct access. But before we plus OM, right? And the space would be another OM. Worst case, for each number we would add an entry into the map. But actually, the problem here is that we don't take the advantage of the sorted information, right? They are both sorted. Our approach here doesn't care if it is sorted or not, right? So if we just sorted, actually there's an asterisk here. We would just check the head, right? If it is smaller than it, then there will be no numbers after 2 here. For 1, if it is smaller than this, then we could safely remove the smaller one. Once we find something equal to each other, that's the intersection, right? And then we move both out of the array, right? Yeah, so that's the case. I think so. So for that, we would still, if we keep shifting, we would max. Still, I think it should be n because we have two actions, right? So n plus m. It's the same, but every time we shift, there will be a index shift for all the other elements. So we need to I think we need to reverse it first, and then popping, right? This will be faster. Yeah, so let's do it. So this is the best approach I can think of. So the first one is we need to reverse it. So what's the time complexity of a reverse? We could keep swapping the elements. I don't know, it should be linear time. Anyway, to reverse, I keep swapping the elements. Yeah, I think it's better. but maybe not that better. Anyway, this is so out of my concern about the index shifting. Okay, and then now we keep popping, right? So while r the length, if there's elements in both array, okay, I'll collect the result, empty, and top 1 equals ar1 dot length plus top 2. If top 1 equals to top 2, then this is the intersection, right? So result, we push top 1, and then ar1 we pop both of the arrays. Pop both of them, and then if top 1 is smaller than top 2, then there is no chance that top 1 will meet another element in the second array. So we pop the first one. For the other case, top 2 is smaller, so we pop the second array. And finally, return the result. The result is a way to hold the element so it takes up no spaces. Let's take a look at the whole time complexity. Reverse linear time on plus om, and then we would loop through all the elements. Still, yeah, like twice 2m plus 2m, right? Pop, it's linear constant time. Extra space, no, because this is for the result. It doesn't count as the extra space. So I would say the final time complexity would be this one, n plus m, and the space would be constant. I think it should work. Great. This one is interesting. N plus m, 01. Okay, so I'll put my code in the discuss panel. Hope it helps. See you next time. Bye-bye.